Here's the main part of this test. I would probably do problem 4 first if I was taking a test. But anyway, draw the free body diagram. So make this little loop here. Draw everything in a loop, which I've already done here. There's this 4 kilonewton force. On the test, you might have something like this, like a uniform load, maybe a triangular load. I won't put like a cosine load or anything more complicated than these two. Be sure you know how to do that. Anyway, back to our free body diagram. I've drawn everything in there and then everything I cut through. So you need to know that a pin has two reactions, Y and an X, and a roller has just one reaction, which is perpendicular. And I figured out that if the incline was 30, this is 30 from the horizontal. And again, how I did that was I drew this on the side, really exaggerated. There, that's perpendicular. So that's obviously, theta's obviously 30, the small angle. There's the free body diagram next, and that's worth 10 out of the 40 points. That's a quarter of it. Write out the equations of equilibrium. You will have 3 equations. Take the moments somewhere. You can do whatever you want. But I took the moments about A to get rid of 2 of the reactions. And so taking moments about A, you have the 4 at a distance of 6 meters. It's going clockwise around A, so negative. I always take counterclockwise as positive. Then you have the Y component of RB cos 30, and its distance away is 8. The X component of RB goes right through A, so there's no moment. I did some forces in the X0, RAX going to the right, RB sine 30 going to the left, that equals 0. And finally, some forces in the Y direction equals 0. You have RA going up, RB cosine 30, the Y component of RB going up, and don't forget that minus 4 coming down. Okay, we can solve that first equation, some moments about A. We can solve that for RB. That's why I picked moments about A. I knew it would have only one unknown. So solving that, you get that the RB reaction is 3.464 kilonewtons. Okay, then I'm just going to solve the Y equation, And so I have RAY plus RB cosine 30 minus 4 equals 0. Now what I could do is I could put this 3.46 into there, and cosine 30 is 0.8660. But what I did was I noticed I already had that RB cosine 30 was 3. I saved myself a little bit of time, and I basically did it because I didn't want to do the round off. I didn't want to have round off error. So I end up with RAY plus RB cosine 30, which was already up there in equation 8, is 3 minus 4 equals 0. So I know that RAY is exactly 1 kilonewton. Finally, I can get the X components by doing this. RAX. Okay, this one we don't have anywhere, so I had to put in the 3.64 for RB and sine 30, which is a half. And you get RAX is 1.732 kilonewtons.